Now, it should make a bit more sense. We have control of a head request that basically includes all the payloads which are added onto this as fuzzers. We can see what goes on the wire, and little things like return characters are actually converted to \r/\n, and you have control of this. And finally, you get responses back, and you can graph these responses. So all of a sudden, it all starts tying in. Okay, that's all very good. And scripting is also very good, and I've briefly touched on this, but how would someone wanting to use Java for fuzzing actually use JBroFuzz? Well, it's a two-step process. You'd have to use this iterator class of the fuzzer, and you would have to go and access this file here, which contains all the payloads. You can implement your own in here. Having done that, then it becomes, regardless of the actual payloads that you're using, it becomes a 15-line code exercise. So, okay, this example again is hex, straightforward, but we can replace this with any, we can replace this ID with any of the IDs that we have here in the payloads category. So, when you're implementing a public API, especially for the process of fuzzing, make sure that what you're giving actually simplifies what the user is trying to achieve. And again, it doesn't matter if it's URI exploits, or it would just be 15 lines of code that actually trigger this scripting vulnerability, the scripting process around generating these values. Okay, so what are you going to see from JBroFuzz in the future? Well, little things like an installer, which has been implemented in version 1.1, support of different authentication, NTLM, basic, etc. Being able to proxy, and also focus on being able to graph these results in many different number systems. So the example that I gave you before, if you actually look at, let's just send one request here, and again, if the connection, yeah, I can see some traffic. Okay, so we're going to get a single point back, but actually graphing the responses in a meaningful way is very beneficial when you're dealing with 20,000 responses. So over here, you've got the file size of what's coming back, and that probably varies, and that's a hint of what's happening. But that's not a set metric, because quite regularly that will vary in a way that's not dependent to the process of fuzzing. So there's a hash value, so we're hashing the response that we're getting, and we're seeing how much it changes by summing up the hash every time that happens. And that's normalized to a value of 0 to 1,000. That's actually more useful. You can catch Apache date timestamps in a normalized graph. So in terms of the roadmap, these are the areas that we're going to spend more time in the future, and there's also talk about merging this project and using it within other tools, etc. Conclusions, well, if you choose to implement a fuzzer, make sure that you make the process of fuzzing as transparent as possible to the user. No one wants a fuzzer that they don't know what it's doing. No one wants to be logging TCP traffic without relying on the particular tool. Don't obey the protocol that you're fuzzing. Instead, obey the APIs which are being used. Otherwise, you won't be able to reach the protocol. And report the results in a meaningful way. There's a lot of work to be done in our industry in that particular area, especially around metrics. And do allow for iterations around this whole process of fuzzing, addition and subtraction of payloads, changing the values, etc. Are there any questions? Yes?
How does your tool deal with different encodings? Like, one question I had before is, if I wanted to send something to get a 7 or 16 or 32, can I do that with your tool?
Yeah, absolutely. So if we look at if we look at the UTF-8 here, for example, those are the accepted characters. Now, that would actually give a UTF, so let's say we make this 16, that will send a UTF-16 response, and that will come as an accepted char set. That will come back. It will be stored on file as a normal UTF-8 file, but the actual bits which get truncated are still in the file. So there will be some differences, but it won't actually register the UTF-16 characters, because then you get in all the different categories of char. Ah, okay. So, no. So you want basically half of this to be UTF-8 and the other half. Well, remember, we're fuzzing HTTP, so you're not meant to be doing that. Again, okay, it's definitely a feature worth considering. Yeah. How would you actually implement that? Probably, I'm just thinking out loud here, so you'd probably grab all this as... Oh no, the socket is fine, but how would you actually implement it in terms of payloads and fuzzers? So, yeah, so all this would have to be encapsulated in one encoding type. Okay, yeah, yeah, that's... to convert to. Yeah, that's a bit. But then you need a mapping between replacive fuzzer and the actual characters that you're writing.
And that would be impacted by like a fuzzer that has more
More length, yeah. Interesting. No, I'll definitely take that into consideration. So. At this stage, no, because you'd probably know what you're putting on the wire in terms of, let's say that we find the sequel. I think I can see where you're going with this. Yeah, exactly. So you probably want to encode that as a %20, right? I think a feature that just come to mind is the ability to select some text and right-click and say encode to a variety of different. Right. Yeah. So what would you include in the right click? So UTF-8, 16, ASCII, all the main character encodings. Yeah. Anything that can be. Okay. No, I'll definitely take that. Thank you. Definitely take that into consideration, guys. Any other questions? Okay. Thank you very much.